Okay. Asserting here because age restriction is none. And the question is, if it isn't age restriction, is it? Did I forget to set it, or should I use something else? Will that always be set? I don't know. Okay, so we're here. Go downhill. This part fits this parabola, so we jump to the vertex of that. Now we have a point that is partially on this parabola and partially on that parabola, so we get some kind of whatever. So we jump to the minimum of this one, which is already pretty damn accurate. In fact, it's so accurate that now it says minimum found immediately on the new approximation. And that's then 1, 2, 3, 4, 5, 6, 7 digits behind the so even 8 digits precise already. And then the new fit, no, it doesn't matter, we found it. So we are going to fit a 4-3 thingy, which doesn't have any maximums. So we can't jump through that. Therefore we continue in the same direction. Go to -12. So the direction here is that direction. I don't know anymore how I got there. But okay. So we get the value and the derivative at that point. The new point, -12. H direction is left. That must be it then, I guess. Is that not true? Yeah, well, probably true, right? But well, it is left. I guess, you know, maybe it is H direction, but I'm feeling a bit uncertain about this. So maybe the real direction is, of course, the direction that we last went into. So whatever made us go to -12. Well, that is this algorithm. So we find that back and see what that is using. Oh, this is initializing H direction. So that's like literally we go there for some reason and then initialize H direction. Probably based on this step. So yes, H direction is then the direction that we went in last. Let me look at it anyway. This is using H restriction. It's funny because then later that gets reset apparently. Was that nonsense? No, wait a minute. No, yeah, I don't know. Actually, damn it. H restriction unknown, therefore we use H. What is H restriction at this point? It should be printed by scale step. Surely that is printing something. not printing something. Could be 0 then. In that case we go in this direction, which is simply set to the direction from the sample that is the furthest away from the critical point to its critical point. Ah yeah, right. Yeah, let's add some debug output. The out entering. Yeah, I don't think I can print this. I cannot print it. I don't want to add. Well, actually, I can print it. Okay. More debug output. More debug output. What the hell? I can't print it. Wait a minute. Yeah. I can't print sample. What? So can't print sample data. This is sample data. Well, that's just to print a sample. So there was where. Samples is sample data, which has a sample member. So I'm just doing dot sample and then dereference it. Furthest away from critical point is sample something, sample pointer dereference. Okay. Ding 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 ding. Yeah, this 0. Okay, so it's setting the direction to left because 12 is the furthest away from the critical point. So we're going from 12 to -7 something, and then that means that we're going in the negative x direction. And then after that, we decode that again to being left, I guess. I think I can just find that back. Instructions W, the new W is less than the current one. Yeah, that's just that offset, literally the offset again. And this then happens if we return true from handle local extreme. Yes, absolutely. So any other return value? I think we're already no longer in that function, or what? Yeah, probably not. Well, actually, this is a lambda, sorry. I think it was a lambda. This is a lambda, so you can ignore that one. Comment. What is this? Return false. Okay, so there's another return, but that returns false. So yes, if handle local extreme returns true, then H direction will be set. And that's then the direction relative to the last found extreme. And I'm pretty sure that is the correct direction, like it remains the correct direction even. So I should use H direction then. I think I should use H direction. What the hell? Undo, redo. Right, quit. Not scale. This one? No. Yeah, this one, of course. Let's just switch to H direction, which is a horizontal direction with possible values. Left, right, and undecided. Yep. Pop, 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 pop. Horizontal direction. And then of course here we use H direction. Oops, H direction. This means there isn't an extreme of the type that we want. Keep going in the same direction. You want to keep going in the same direction, but what to do if H direction is undecided? Feels like cheating is. Downhill, jump to the vertex, jump to the minimum, continue in the same direction. Well, no, fit for 3 polynomial, it doesn't have what? Something, so continue in the same direction, that would be 5. And now we are not crashing, but we go to -16, so we continue in the same direction, and it should add this distance to that point, which brings me here, which is about -16, so that's correct. And then it should double it. What the hell? It should add this distance, so we should go to, I don't know, -24 or something. Instead we jump back to -7.75, which is totally wrong. Apply. 16, enter 16, H-Rex to the left. Adding it to the history, update the energy, update the approximation. Well, I don't think so. This should call, yep, update local extreme, so it just changes the scale from 4.25 to 7. Now that's not a doubling, but it's because I'm doing something special with the left and the right. So the 7 is the result actually of this left and right combined. If they are equal, it returns one side, but if 1 is 0, it returns also that one side, and if 1 is not 0 but also not as big as the other one, it gets less. That's kind of weird, isn't it? But yeah, 7 instead of 8 or something, was it? We're still going away from the critical point. That's correct. Now, new approximation, I guess that works. Handle approximation, -16. Find extreme. Turning in between. Oh, that's wrong. And that is wrong. So apparently it's happy to return a minimum. Find extreme just finds extreme of the current fit. It's a pink thing here, magenta, which has a minimum here, and then that's what's being returned. But it shouldn't do that because I should have told it to I should have demanded that we go to the left, and I'm not demanding anything. I think that's called a restriction. I'm not sure even. Horrible. Sounds like it, but my restriction is none, so that's not good. Why is my restriction none? And why is this unknown? Just completely reset. Bullshit. This must be a maximum. That would also help. The next extreme type is wrong. Of course, we already know what the next extreme type is. That's maximum. Should have been since we found the minimum. Here it is maximum. So apparently I'm resetting it involuntarily somewhere. Do I print that fact? I'm not even printing it. Well, let's fix that because I want to see where that is changed. No, it kind of says it. Returning unknown because the cubic looks like a parabola with an extreme type minimum different from what is requested. Ah, right. Okay. Okay. So I'm looking for a maximum and we don't find any. Okay. Yeah. So I'm calling find extreme in algorithm somewhere, probably here. And that must be inside handle approximation. It is update approximation. Here we call it, and I'm calling it with next extreme. So then that gets reset. That can't be right. Maybe we should split this up for now, so I can think about it separately. So this code seems to work if next extreme here is equal to unknown. And if it isn't, then I should do almost the same, but really we should do the following. I should call this, but not pass next extreme. Let's do next extreme type. Extreme type is extreme. I'm just passing an extreme type here. Why did I completely forget what restriction means? I have to refresh my memory. So region out is not used, it's just the output. If it finds something that is returned, left, right, or in between, depending on where we find the vertex. Then we did the extreme, basically. Yeah, okay. Depending on WR and WL, which are the values of the relevant samples that we pass. Output. Okay, yeah. Left, the requested extreme is on the left of SL. Yeah, what is it called? What it is? Defined as also, I don't think so. I do. SL is relevant sample 0. Extreme type up, the extreme is maximum, down extreme is a minimum unknown. There is no extreme of the requested extreme type. In this case, if restriction is none, region out is set to the point in the direction where we go downhill. Otherwise, it's set to the direction equivalent to restriction. Okay, this is restriction. I should make sure that this is correct. think I can already set it immediately. The moment we go downhill. Mm-hmm. Right, so this one is always called with unknown. This extreme equals unknown. And then we can dump the output that is written to this directly into this member function. I'm just wondering if that is then correct, because next extreme that is the next extreme that we're looking for. Yeah, okay, I guess so. And then after that, we're calling this. And now I'm filtering again on this value. So here it is again unknown, and then we can just pass it and it's set again. Again and again and again until we actually find something. And once we find something, then that's the keeper. So we don't want to change it anymore. So now I'm pausing a temporary, so that isn't changed after that. Does this should still hold? Yeah, let's just combine it. So I'm going to do this. Pause extreme type here. And what I should test here is of course the return value, so that is just extreme type. And then here I can do if next extreme type equals unknown, then make a copy. Downhill, jump to the vertex and crash. What the hell? Yeah, this is an uninitialized value, so it's probably a magic value, that means uninitialized. That one. Apparently it's using it. Would I already have a value? I mean, with the, what changed? It's like the first time I call this handle approximation. It's the call to handle approximation after the time that we pass minus 3.49. Then let's go to the previous one. So that is this one, and then the next one. Yeah, that was previously also undefined. So I don't think it should just not be using it. And now here it said then left because this is where the required extreme minimum is after calling find extreme. And here we just crash. I think I forgot to remove this. Yeah. I forgot to remove that one. Downhill, jump to vertex. Jump to there. We found it now. Jump. -12. -16. The turning's -23. So it's going to go there, which is not correct. This distance is too small, isn't it? Actually, it's correct. The scale was 7.1, and that's the step that we take. So, yeah, from -16 to -23. Okay, then. No, it's quite a big step. Definitely bigger than this one. And then we go to take a step of 13, which is again the last scale. So it keeps adding scales, it gets bigger and bigger. So I guess all the way up here. And now we go to -62, and then we have more energy. We use more energy than we have. So the next step should be rejecting. I don't like this. The keep going is correct, and then it prints jump to vertex. That's even though the value is exactly the same. That's really weird. Where does this come from? Nevertheless, after this. No, that's also not good. It's not stopping. It just bumped the energy. Yep, okay. Might have to do actually with the jump to vertex. We should have bored on too much energy if we keep going. But if you make a jump to a minimum or maximum, the whole is just bullshit. But anyway, then yeah, the energy would be bumped. Get the same thing again. I guess it just keeps going till infinity. Yep. No. Keeps going forever. The vertex return true. After already having done that, but that would return true immediately. Yeah, okay, so this function sets the algorithm string and then returns, or sets this algorithm string and then sets the state. to extreme jump. Or sets this algorithm string and doesn't do anything. I think I can return here. So checking if we reach the minimum. That's bullshit. After doing this, I think I should just return here. Return true or something. And then this one, find extreme jump, set state. So now what does this belong to? Maybe nothing? No, I think nothing. Just delete it. Every time W is changed, we set expected and the algorithm string and then return. And here, but it's actually an inserted one. Oh, never mind. Here W is changed and we set immediately expected. Then we do this detection and then we return true. And here I do the same. We set. Oh, wait a minute. I set new W. Not setting W here. There's no reason to come here, so there's no reason to set new W. So mostly because there's no need to do this test. That would only necessary if you do jump to an extreme. Not if you keep going. So I think I should do W plus is this. And then indeed a return true. Yeah, and here I'm setting new W, but I'm not setting expected nor the algorithm string. And then if this holds, then we just do not return. And then we get here. Then we set W and expected. So this still needs an algorithm string. So I could set that here indeed, which is then the one that belongs to the algorithm used to set new W. Maybe I should set it then at the moment that we reach, the moment we set new W. And continue, which could be here or well here, basically. So this is then jump 2. Extreme jump. I think I have that somewhere already though. It's kind of weird. Find extreme jump. Okay, so in this case, new W was set by find extreme, and then I do find extreme jump. And in this case, it's also set by find extreme, but yeah, could also call it find extreme jump then. Maybe I should do that. Find extreme jump. It's literally the value returned by find extreme, so there's not really a difference between these two. Let's see if that makes more sense now. Jump, 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 jump. Okay, now we have just keep going. Keep going, and then this one, the next one, I mean, is definitely too large. But kinetic energy is still not killed. So now let's have a look at this call then. Where is this being called? That is in algorithm operator. Update energy. Okay, so the problem is that the state does not check energy. I should set that. That causes us to go aboard. So too much energy. And that, like I said, that belongs to the, well, I could stay in this file. That belongs to the keep going algorithm. Okay, these two mean we try to find a jump point with the 4th degree polynomial fit, but it doesn't have any extremes. So we just continue a little bit. That should by definition basically be so little that it definitely should not use too much energy. So I don't feel like setting the state here. Yeah, maybe I should look for step instead. That is actually the exact point where we're doing something that might use too much energy, right? So this, I won't do it here, but then this one, yeah, definitely should. And I'm setting state to done, so that's wrong. Or, wait a minute, this is the downhill thing. Yeah, well, you don't have to check energy either, of course. Just going downhill. Okay, let's find the next one then. There it is. This is to keep going on. And then we go around. Okay, so this is the one. And the only thing I'm not doing here is setting the state. Got to do that. Keeps opening there. Okay, down, jump, jump. Keep going, keep going, keep going. Is this already too much energy or not? Probably not. One more. Yeah, that looks like too much energy. This one already. Too much energy used. Okay, so we are boarding left, which means that we are going to jump to the minimum and then add the scale. Let's see. Boarding left of that minimum, entering extreme done. Locking extreme done for extreme. That explored is left. Change horizontal direction to right. Restore W to the best minimum. Best minimum opposite direction. That's at 5.4. So we jump to 5.4. That's here. And that is just this best minimum that we had plus the scale. So it's kind of opposite of 7. More or less-ish. A little bit less than 7, right? Because of the way I calculate scale now. Okay, so then we are here. And we did a reset apparently, so now it's just a straight line. Support is left, change horizontal direction to right, sort best minimum opposite direction. Yeah, that's where it was. Entering local extreme explored right for extreme at -7. Explored is now left right, so we explored both directions. Next extreme type is set to maximum because we just jumped to a minimum. And kinetic energy set is now that. Entering algorithm reset history. There it happens. Skills reset. Tuning 5.4. Entering algorithm with 5.4. Each direction right, next extreme maximum. Adding to history, pending is 3.9, that, kinetic energy, whatever. Update approximation at 5.4. Should we be doing that? Because everything was reset. Okay, it starts over. Yeah. We're looking for a maximum, I guess. We just start over, and then update scale. This is the first sample. We have just one sample. It says. Okay, I'm getting it. So the parabola currently is a straight line. I'm going to remove the parabola, so the cubic should be also. Q is not printed. Dude, what the F? Huh? Why is approximation not printing my cubic? Maybe because I have only one. Yeah, yeah, okay. Well, I have only one sample. I think that's the reason I'm not printing it. And the scale is not really reset, is it? Keeps all the other samples still in it. Yeah, it's no good. I think I should reset it really. Like if I reset the scale, then we have to erase all the samples. And single sample. Small step. It just wants another point. But you're going uphill, right? Yep. Very uphill even. Oop. And crash. Trying 18. Add that to the history. Kinetic energy. Update approximation. Add 18. Parabola fit. Cubic is now there. It still looks very much like a parabola. Update the scale. Scale update. Yeah, that has a critical point that is a maximum at a negative value. Well, there we are. Assertion samples empty field. That's exactly what I already realized. Okay, so not super interesting. I should just reset samples if I reset the scale. So I'm having a scale somewhere. And then that has a reset, I think. I hope. Yeah. And that should erase all the samples. It's called clear, I think. If it compiles, it works. Well, I mean, then it clears my vector. Pretty sure about that. Yep. Okay, there we go again. Doom, 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 doom. Couldn't. Let me crash again. This time because oh. I don't know. I'm gonna assume that I didn't do the reset correctly. That is not enough. We have more stuff. Value set to false. Value I don't care, I guess. So these two must be initialized, maybe. Yeah, valid is false, and why would I care about those things? But on the other hand, yeah, they're not initialized at all. Initially. Okay, let's run this in a debugger then. See if we get it then. Well, that shouldn't fail. Yeah. Bug in the boost container defactor, I think. How the hell can that go wrong, man? It's just an empty vector? With still a capacity of 6. Bullshit. I think the clear is not working. It's broken. Yeah, let's see if someone else found this. So the problem is assertion that Apparently not. Nobody in the world ever ran into this assertion. Okay then, description, DE vector assertion. Talking about vectors, dude, I said DE vector. Seems I'm the only one in the world using this. It does not sound like the Okay, nobody knows about it. Well, in that case, I think that what is wrong here is I have no idea, but the values are different. So I'm doing a clear of the DE vector, and after that it behaves different than after you just constructed. After it was just constructed. But of course, the whole assertment is like proof already. I think that it is buggy. Don't have time for this. I should report a bug. It means write a small test that reproduces it. Okay, so I'm going to set a breakpoint here. 2658. Run it from the beginning. Would this be the first time that we get here? Place front. So samples is empty at this point. See, back ID is 7, capacity is 8. Instead of being 0. And a capacity of 6, but well. But nobody knows if we should move back. Probably, I don't know. Print. I mean, the back free cap. What? Dude. Oh, I have to go to frame 0 again. GPS. Okay, so the front free cap is less than n. But the back free cap is not less than n. 1 is not less than 1. Therefore, this is certain does not fail, then this must have been tested. So this must be false. It's true or false. And this is false. This is false, and I guess I'm not doing something with back and doing something with front. No, I am, because I'm doing in place front. So next, and it does not crash. Okay, to continue. And now we have, wait a minute, I can't do that. Let's go up. Again, the in place front. And the samples is now having a back ID of 0, which makes it fail, the assertion. I think this is wrong. Why would back index be 0? Okay, let's have a look at the code. Quit, yes, we are. Back free cap is returned from back free capacity, whatever that is. Well, actually, that looks very much like this is the default constructor, and it says that the post condition is that the back free capacity is 0. Very confused here. It is M capacity minus a back index. Okay. Wait a minute. Capacity minus back index. Not really getting it. Let's try to write a test case. Vector bug. This should not crash, huh? Because that worked before. Pretty sure of that. It does not crash. Good. Now DV clear. And now increasing the capacity by adding stuff in some order, but nobody knows which order. Yeah, I can just. I need to get the capacity to 6. I think I can just. I don't know. Add a few things. Let's do DV and place front. I'm beginning with the front anyway. And then a back. And then I don't know. Let's add a few backs. Yes, we reproduced it. Well, obviously this should not crash, huh? I mean, come on. There's something wrong with the clear. Now let's start to simplify it. I'm going to start with making all the in places just insert, I guess. Push. I'm not sure which one. To place, sorry, substitute in place with, I think push. Yep. And then let's try to make this a back as well. Yep. And let's try to reduce the number of push. Okay, well, that worked. And I guess I don't even have to do this one. Someone having a phone call right in front of my open window. Okay, what was this? Yeah, IP. Yeah. Hello, Matrix 99. Yep, that's the second one that crashes. Yeah, so, okay, no needed. Compact. Assert. No assert. And assert is copy. Oh no, how to report a bug. Guess I should make this a little bit small. Report boost bug de vector. I don't know. How to report bugs. Detector. I'm really the first in the whole world who uses the vector. Well, this just seems like a bug about the vector. Container, okay. Yeah. Container issues. Let's have a look if there's something else there. No. For example, include the E container is just part of this. There it is, DE vector, I mean. Is this official? Guess so. Boost org / container, yeah, totally official, right? Report bugs. Be sure to mention the boost version, platform, and compiler you are using. So that is this site. Submit your patches. No, thank you. Discussion about library. Yeah, I don't have time for that. Let's just report the bugs. I don't have to do that here, really. Oh, that is issues. Okay. Now I have to make sure that it doesn't already exist. Well, I googled it already. That's all. Well, I don't see it. Definitely nothing here. You seriously want to know how I learned C++ 30 years ago? Times have changed. There wasn't even internet when I learned C++. We all know that it doesn't matter, but I insist on receiving this information. Right. Well, that's enough for me. Both fail. I reported it. What is this? Preview? Right? Preview? Oh, I can click on that and now we see a preview. Okay. And I'm logged in as who? Just code. Okay, so GitHub. Now how to solve this, because I'm not sure I want to kick the E vector out because of this little silliness. Extremely annoying. Yeah, it's broken. I should kick it out. You have to write everything yourself, it seems. What to do? I have not a samples. Shit. I think everything in scale is referring to the samples that I'm using. And this is using brackets. Okay, what else do we use? Default construction, brackets, back operator, front operator, size, clear, and place front and back. Begin and end, so I need an iterator. Distance must work. I don't know what that uses. Just a dereference of the iterator, I suppose. A normal in place. Okay, yeah. I used to have a better memory than I have now. It never occurred to me at that age. When I was even younger, because I started pretty late, I did 30 years C++, so I started when I was about 30. With C++ it is. But I programmed longer. I started coding first when I was 12. There was a time that I did not understand why I would add comments, because I just could remember everything. Everything. There's no need to write comments when you just know you just remember that you wrote it and what it does and where it is. I would just have the whole program in my head. And then at some point people convince you to write comments because, but if someone else has to read the code, then they need it. And that was understandable for me. It never occurred to me that I would myself forget something. And now see me, I forget everything. It's like I'm continuously working on code that someone else wrote while I wrote it myself a week ago. Okay, it's not that bad, but pretty close. Now, shall I write my own DE vector or not? And if so, then how shall I do it? Because it has a few... I think it's going to take me at least a whole day to write it. It's kind of stupid. Maybe find something else. Maybe ChatGPT knows. I found a bug in Boost container DE vector and can't use it, therefore. Do you know of an implementation by some other library or GitHub project that has something like it, that is continuous storage, cheap insertion at front and back. You are not allowed to... She just writes it. That's great. Yeah, well, it should not mention DQ because, dude, that's not continuous. Which then makes you wonder if maybe the other stuff is not continuous. Inline vector. I guess I mean on the stack. Mine is really small. Might as well do that. So a fixed size check size vector. Yeah, can I use that? Oh. Yeah, no, not really. Not. It's always possible that at some point the thing grows out of bounds. So I don't want to run that risk. For the rest, I don't know what inline means here, of course. That is what it mentioned, isn't it? F14 vector. Why does this thing not even explain what it does? Where the hell is the insert? I think I should just do Control F front. We have a front. Push back. Yeah, it does not have a push front. That is not it. The F14 vector, but there is no F14 vector here. This is a map. Okay, we give up on this one. I don't like Facebook anyway. Upsile. Container. Flat. Inline vector. Okay. Okay, you can pass a static size, but if you go beyond it, it's still going to use the heap. That's then good enough. But I still have to see anything related to front. Front, of course. We do not have a push front. Nope. ChatGPT is lying, as usual. You have push back, but no push front. Well, that's a red flag, right? Don't use this. Yeah, okay, Matrix. Thanks for hopping in. How is this one called? Just Vector. Nope, also only pushback. No, crap. No, I didn't add everything. No, okay. I feel like writing it myself anyway, so let's just do it. Blah. Okay. Shall I put it in utils? It's kind of a utils thing. Utils. No, that begins simple. Just something that's source T objects. Think about whether or not I want to restrict it to trivial copyable. I think I do though. I can probably use a standard copy or standard move. So this is a standard move, something else. Can I use standard copy for overlapping regions? I'm not looking at C++. What a horrible implementation. So it looks like you cannot use it for overlapping regions then. I mean, just looking at the implementation. Yeah, so it cannot overlap. Oh, it's just, okay, yeah. So you have to copy one or the other based on how it overlaps. They couldn't add that test apparently inside of it. Hello, Bendy, I'm using Arch Linux. Well, I'm not sure. I mean, I would say that this thing should check if whatever it is copying is trivial copyable, and if it is, then use standard mem move or something like that. Standard mem copy. Iterator is the hardest thing, but I'm just going to use a pointer as an iterator, I think. Let's make iterator is simply a pointer. So the const iterator const pointer. So then I have a begin and an end, or need a begin and an end. So that would be iterator begin. And well, I put the const first, so const iterator, const, and then the same thing for up, same thing for end. What else did I use? I used the emplace. Yeah, so emplace front, emplace back, and then I guess I have to do the pushes as well. Push back, push front. Yeah, I had a clear. I'm not sure what else I did call. Oh yeah, the operator. Square brackets. Index. I can put that one higher. Let's see what this interface has to be. Place front. Maybe I should have looked at place back. Anyway, this is just in place. Okay, that's a template. Args. Copy. Const expression. I don't like class. Victoire. I'm surprised that... No, I'm not surprised. Never mind. Const expression since 0 plus 20. Let's see if I can do that. Also const expression. Size type const. Constructeuren. Everything is const expression these days. Bracket operator. Yep, const expression. It's a size type boss. No, okay. Yeah, also reference, a const reference, of course. Const reference. Reference. Const reference and reference. Const reference. And reference. Place I already have, and I have a place back, and I might as well add in place front. I mean, that's gonna be the same thing, right? Same signature. And let's see, back, I need a const reference. And then we need also const expression. Begin. Also const expression. What? Nobody knows why this is not a reference. Yeah, whatever. T-cons reference. Same thing, of course, but still. Value. And then again for R value reference. And then of course push front is just the same. I think the counter of the place is probably insert. Not using it, but let's insert add insert as well. Oh, there's a lot of inserts. Should add pos. No, yeah. Or move. Count of them. Well, I'm not using it. Why would I spend time into adding an insert when I don't use it? Because I'm adding it to utils, which means that must be a complete. Sort of. Guess I'll add these two. Yeah, I should add an empty, I guess. Assignment operator probably also. Data. Nah. I think that's everything I need. Huh? So let's place this with utils equals d vector. The vector is broken. I shouldn't be doing this. I have to. I mean, I'm abusing double quotes to tell me that I wrote it. But really you should only use double quotes for when it is the path is relative to the current directory. And there is no utils in gradient descent, so yeah, I should just use angle brackets. Well, habits. What is this? This is expected, but then I got errors here. Inline function, it's not defined. What do you mean inline? Oh, it is used. Well, just a warning. These are just all warnings. Warning inline function. In the end, it does compile. Warning inline function, warning inline function. Let's go to the end. 16 warnings generated. Okay, so it works, I guess, except for the linker errors. Okay. Okay. Well, let's implement it. Let's make an implementation of this thing. I think I have to initialize that with an empty buffer. But I do need a size. The size is 0. Yeah, in case capacity is not 0. To put a 0 index, which is then the index into the buffer that corresponds to index 0 of the vector. Put that somewhere halfway. No, wait a minute, that's not correct. Well, it depends on the size. The size is now 0, so yeah, then it is halfway. Then we have the same capacity for pushing as for pushing front and back. Has the same capacity. Empty, yeah, well, boring. This thing comes with no checks, huh? We can just return the buffer. The buffer at the 0 index plus pos. Oh, this was an easy one as well then. Return buffer at 0 index. Back is actually easy as well. That would be the 0 index plus the size minus 1. The iterator begins also extremely easy. That is namely the buffer plus the 0 index. And this then would be surprise, surprise, same thing. Oops, I missed the return. Turn. And the end is equally boring. Well, actually not exactly equal. Size. And again. Okay, that's more complicated because now I have to do a check and then reallocate if it doesn't fit. The same for that one, same for insert, same for in place, all of these, yeah. But the rest needs checking. If there is room. How shall we do that? I think I can implement the pushes in terms of... No, not really. Insert should be moving stuff, so that these are definitely simpler. Okay, let's make up something. So if something, then do something and then return. No, let's first do, if you're out of memory, then allocate memory. And after that, you can just add, I guess, to the end. So that would be buffer something becomes value. And that something is then always the 0 index. Starting to think that maybe I should have a pointer here. Nah, that's an assembly instruction that adds integers to pointers. It's just a way to address, so this is already infinitely fast. So the buffer 0 index plus the size, and the size must be incremented. That seems about right. Yep. Yeah, I don't like this. Let's put it on multiple lines. Better readable. No, I think that the only reason to take some action here is when this doesn't fit. So if this hmm. That's nonsense. It can only be full. This all feels like nonsense, or is it not? So capacity is the size of the buffer. So I say capacity is 2. Then the size of the buffer is 2. Therefore, you can at most assign to 1. So it is not correct. This must be capacity minus 1 then. And let's increment size in advance. I'll just subtract here. Zero index plus size. So I am using zero index. Waha, and I thought it was not necessary to initialize it. So if I set that to 0, and we call this here, then we get 0 plus an incremented size equals 0. Yeah, and that's not true because whoopsie. So maybe I should initialize 0 index to -1 then. So then I can just use this. So the first time we call this, we get -1 plus, and size is incremented to 1. That is 0 equals capacity, which is 0. And then we get to allocate the memory. And then after this, 0 index is something else. But then it will fit. I'll make sure of that. That is my reallocate. Now must know how many things will be added, but well, there's only one here. But I'll have to pause that, I guess. We must pass the number of. I mean, the front and back capacity must be passed, I think. Could do 0, 1. Absolute minimum. No, that's the same thing. I hate this code duplication. I might as well. Oh, wait a minute. It's not true. Sorry, I thought it was just a const reference. So this is the move thing. Okay, standard move then. For the rest, it is the same. The push front is probably very much like it, so I'll begin with copying it. Except, yeah, now we have to add something in front of the 0 index is element at 0. And I want to put something in front of it. And then that ends up at 0 index. So we're going to do the same thing. And here the 0 index is decremented. That's not going to work. 0 index is already -1. But I'm also no longer interested in capacity, actually. I have to subtract from 0 index, and then must reallocate if this becomes less than 0, I think. And then I need at least one space there. So if there was room, then 0 index moved 1 back. Still not less than 0, and that's not working because it's a size type. Yeah, you should never use size types. It's so stupid. I don't like size types. Normally I just use ints. I mean, come on. It's we have a signed size type? Guess we do. No, okay. Let's see. Font less than 0. Allocate. Otherwise, we can just assign it to it. Looks like it should work. Yeah, this is more complex. Definitely more complex. This one too. And in place is kind of the same thing, I guess. Again. And place back. Might as well move that up. Implement that here, and then the place front. Implement that here. Okay, there's still a problem here. If I start with a null pointer here, and I call begin and end, then that should work. Right now, I would get buffer -1 as begin. And also as end. Oh, well, maybe not that bad. No, because that does work. Yep. Okay, and place back means I want to construct the thing in place. So I definitely have to do the same thing as with pushback for the reallocate. And then, yeah. It's a new with placement, I guess. New, some placements. T. Args. Okay, and then this must be the pointer to the correct place, which is just back. After already doing that, I mean, pushback is putting it here, and back is, see, the exact same thing. And then the pointer is one less than end, but let's not use that. So the in-place front is the front. Okay, push front here. And then new add yeah, okay, that's not good. I need standard forward. I've got. Well, like this. Penalty. Oops. Where's the other one? Here. Yeah, if you have a template with two ampersand's, that's not an R-value reference. It's called, I think, a universal reference, which must be forwarded. It's almost an incantation. I'm not really getting it. Probably it's possible to really understand it, but I'm just copy pasting. Okay, so they have almost everything now except for these three, where I'm not using insert. So except for this one, it should already work. Well, no, it's not true. I still have to write reallocate. Let's see if we did that one correct. So 1 0 is required for every front, yeah. And then 0 1 for the pushbacks. Okay. How do we do this one? Let's start with this one. Place at position. Well, I think the reallocation requirement is exactly the same as push back or not. No, because I want to move as little as possible. I think I should just check if I want to move the part that is at the front or at the back. And then we know more, as it were. Getting cold feet. Don't something. And close them. Dus. What was the place in the middle? Either it needs to be return a reference, which is a pointer in my case. No, it's not. I need to return. Is it new returning a pointer anyway? To return the dereference value of the new. Really? Only find reference to in place front, in place back, in place front, in place back. In reallocate. Well, reallocate I get. Maybe the rest because they are calling reallocate and they are in line or something. Totally defined, looks like it, isn't it? I think I need a header for a new though. Placement new. I don't. Confused. Anyway, let's try adding implementation haha for reallocate. Yep, that was it. Okay. Right. So Yeah, this is a difficult function. I'm going to write allocate first. There's just zero index, I think. Zero index is 0, then we don't have anything. If it is 1, then we have 1. Let's make this... I'm just gonna cause it, I think. Yeah, well, no, because it can still be -1 at this point. I think that's a wasted test. If we don't have a buffer yet, then allocate it. I think I've got something with storage. Storage, maybe I should use an allocator from the get-go, but I'm feeling not up to it. Online storage. Yeah, nonsense. I need to use the allocator. How do you do that? Oh, ChatGPT did write something. Let's see if it called that right. We allocate. Totally not doing it right. Yeah, she's using an array thing. She's not using the allocator. It doesn't even have an allocator either. Well, mine does neither. Oh boy. Should I do this as well? Because if this is trivially copyable and it doesn't have a constructor. Publish that done, man. I don't know. Personally, I would just allocate a char array. I think ChatGPT is wrong again, as usual. Yeah, it must be a char array. I'm using this, I'm having this myself, of course, somewhere. So probably one of my allocators. Let's just open a new window, a new tab. Go to utils. Grab here for storage. Nothing. What is this? Aligned? Yeah, aligned alloc. Guess I was looking at the wrong thing. Allocate size bytes of uninitialized storage with alignment is specified by alignment. That's what I want, right? No. Aligned alloc. The alignment. How do I get alignment of T? Got that as well. You just align off, I guess. So like size off, align off. Yep, a line of type. A line of, it's a keyword, T, comma, and then the size. In bytes, so that would be size of the times the number of elements that I want. How many elements do I want? Hmm. Eight, 16. Initial size. Front cap plus backup size. Yeah, that's going to be the capacity, right? Capacity is in elements. This is the capacity. The size is still 0 then. It was already initialized. And the 0 index, yeah, should be somewhere, put somewhere halfway. capacity divided by 0 by 2. So now, if buffer is already initialized and we get here, then at least the 0 index won't be -1. Oh, it's just overwritten here for all the previous call. The current back cap is yeah, Gonish. I'm like way late probably, noticing your eye. Current back cap. Let me have a look at Discord. Yeah. I'm not even sure if the cost is necessary. Can you just not assign it directly from a signed size type to a size type? Because this would be the capacity minus the 0 index. And what happens if you subtract a signed size type from a size type? Is it then a size type or a signed size type? And if the result is a signed size type, then I'm still assigning that to size type. Or I would have to do a static cost around this as well. The whole thing feels stupid. I'm just going to do it like that until I get a warning, I think. Talking about warnings. Not refer to. Well, that's because I changed it into 2 apartments. Oh, it's a void pointer. That must be cost. And can choose a static cost here. To cost it to T. Zero index and that. Okay, I took front and back capacity, and now I want to do what? I want to let me think. What I was, if I run out of if you run out of the front or back capacity and it still fits if you just move everything, should I then move it or should I just make a bigger allocation? I think you should move everything. Yeah. I think that the problem was that sometimes people use this as a queue. So they insert it in the front and they remove it at the back. That's the only thing they do. Every time reallocated when you get at the back, then you just waste a lot of memory. at the front or the other way around. But yeah, on the other hand, if then you're at near capacity, then every insert would cause all elements to be moved just to not reallocate. So I think I should reallocate unless the capacity is like much bigger than what I need. So with like you just use a small fraction of the total capacity on one side, then it's better to move it. Maybe like the same thing as the growth rate. The growth rate is usually factor of 2. Kind of depends, I guess. When it's small, you increase it by 2. So not a limit. I mean, if I have a megabyte already, and then do I really want to make it 2 megabytes? And then 4, and then 8. At some point you just want to add a fixed amount, I guess. Well, making it too difficult. Let's just double the capacity for now. Period. So you want to I have to do some ASCII art, I think, because I'm not seeing it anymore. Oh, talking about which, then this is a bit vague. I mean, maybe I want to have a power of 2 anyway. In fact, I don't want to have a power of 2. I want to have, oh boy. I must be in the neighborhood of where I'm using something like malloc size. Not using it. I have a feeling that my memory allocation stuff is some in a different Git submodule or what? Giving a minimum number of required bytes, this function returns a possibly larger size such that the used heap size will be a power of 2. Or something that fits in a fixed number of page sizes. So I can just, that is a nice power of 2, right? So I can just wrap malloc size around it. Excusez-moi. Well, no. Damn it. And we need to have size type. To allocate all these bytes to allocate. And then normally I would like to do capacity times the size of t. Oops. So utils malloc size. But well, let's use a menu variable. Minimum capacity. Right, and then from that I can recalculate the actual capacity then again. Divided by the size of t, rounded down. But yeah, it doesn't really matter. I could do this or just bytes to allocate. I don't think aligned alloc has no overhead. Actually, it does have overhead, of course, because of the align of. But yeah, I think the align of t is going to be less than 32, so it shouldn't have any influence. I'm not sounding convincing, not feeling convinced here. The problem with this, I mean, on one hand, we are being very efficient now with memory. I mean, if you allocate 12 bytes and you get 64 anyway, then it would be nice to know that you have 64 bytes and not think that you have only 15 bytes or whatever you thought you were allocating. So this increases the size so that I know that you will have that amount of memory. And then we can actually use it. But on the other hand, then we have something that fits exactly. You shouldn't allocate a little bit more, because then maybe the actual amount of memory is going to be doubled under the hood. So you're wasting a lot of memory again. So if this allocate, if I can pass this to malloc, that's what it is made for. But if I pass it to aligned alloc and that thinks, oh, but I need an alignment of t, so let's allocate a little bit more, and then whatever I get returned, I'll just add something. I add something so the alignment is correct. If that happens, then the shit hits fan, because that means that if it always adds, say, alignment of t to the total size, so I can add that, then we will always get the double amount of memory allocated, at least. Not sometimes, but now in all of the cases. So we can mitigate that by making it the capacity 1 less, and then we know for sure that it won't happen. Or I can assume that aligned alloc is smart. And then assume. And then hopefully it is. Because if it is smart, then it will never have to add anything. It will just know that if it allocates memory, that it will be aligned already anyway. And therefore does not have to allocate more. Just in case. We'll never know, I guess. Yep. I think I'm just going to subtract it though. Yep, and then this no longer holds. I have to subtract 1 from this capacity. And then here we have to also subtract size of t. Or I subtract it here. Totally making it less efficient, but well. It sucks. I deliberately choose to lose one whole element, because if I don't every time, because if I don't, then I might be losing half of my buffer. That looks like less efficient. Right. So we have, say, a buffer which has empty elements. Yeah. Maybe I should triple it. Nah. Hmm. I don't know. This is a bit fake-ish. Just one on this side. Yeah. I'll never have a capacity of 3 anyway. Minimum was 8 now at the moment. Yeah, I think the capacity is going to be... Okay, I just subtract 1 now. Dude, I have no idea. My capacity is old or even now. It's a result of that. Okay, anyway. Going to be larger than 8. It could be 9 now or something. 11. 16 minus 1 is 15. Could be 15 instead of 8. Ouch. No. Okay, anyway. I'm going to say therefore Yeah, 1, 2, 3, 1, 2, 3, you're gonna need 4. So let's delete this. That becomes 4. Yeah, so what is the reason that I do not want to reallocate? Because if I move, I have the same front and back capacity as when I double the memory, which means that the sum, I mean, if I double the memory, then this plus this is equal to the previous capacity. So if this plus this is equal or larger than the current capacity, then I don't have to reallocate it. Wait, that's nonsense. Capacity is 10 here. I mean the size then. Size? No. What? No, it is half full. Okay, so the reason that this is okay is because in the end, 3 is going to be equal to 1 plus 2 is 3. Where it is, it doesn't even matter. I'm about in the middle. So since size is less than or equal half of the capacity, I'm not reallocating. Yeah, finally. Hey, DevTune, I'm re-implementing DE vector of boost because I found a bug in boost's DE vector. I'd rather write my own than that I fix that. Yeah, and then if capacity is odd, then we're rounding down and then use the equal thing here. Maybe we should just do less then. Well, equal would have been good if the capacity was even. The capacity is odd. I'm rounding it down and I want to have less. Then, yep, no, wait. Okay, that works also if capacity is odd, I guess. Return. But means that we move stuff. If const expression something, use memmove. Else don't use memmove. Is that a thing? It is a thing. Struct is a struct, however. That's a boolean. Did I write it correctly? Copiable, triviale. Yep, I think so. It is defined in type traits. Okay. I guess we have to work with addresses. I'm going to use memcopy because I don't trust standard copy. Is that stupid? Probably stupid. Yeah, it's probably stupid. I mean, no way they will have not done that, right? Testing if it is trivial copyable. No way. Okay, I'm gonna trust this standard library here. So I'm going to use copy, but it then depends on which way we copy. So let's first implement it for this case. Copy it backwards, so that would be standard backwards, right? I still need a from and a to. Those are still addresses or what? Copy, 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 standard copy. Copy n, is copy n more interesting or not? It's working with a count. You know, memmove is working with a count, so it's tempting. Nah, I'll use a copy. First last and then destination first. If destination first is in first last, then behavior is undefined. So if we copy backwards, then that is never the case. I would call this copying backwards from here to there. What the F, dude? But I might still overlap. Yeah. No. Yes. No. No, 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 no. This is the first one. This is really weird. This one, well, it's called not backwards because we start with the first element. It's copying first. So we're copying A first and then B and then C, and that's how we want it. Yep. Standard copy. Begin, end. I already wrote those, and they are super inline, super short. So copy the whole thing to, and now I need this thing here. Where do we move it to? Well, that would be, I can just use a pointer because my iterator is a pointer, so I just want to have the pointer to this spot here, which I can calculate from buffer plus new 0 index. And the capacity did not change, of course, and the size did not change. So this should be it, except that I still have to calculate the new 0 index. And what is that going to be? Well, that is going to be 4, because we have 4 here, which is half of the sum of that, which is the capacity minus the size. So half of the capacity minus the size. No, that looks good. And if this is not the case, then I do want to reallocate. Cannot really reallocate. I just have to determine a new capacity and then allocate a completely new block and then move it over. And then free the old one, the old buffer. Lots of work. Did I not forget to update something here? If I just change 0 index, it's the only thing I have to change. The buffer doesn't change, the capacity doesn't change. The capacity does change. No, it does not change. Not. No, yeah, okay, just 0 index. And moving stuff. Correct. Oh wait, this is moving backwards. I'm not sure if I want that. That depends, of course, on which direction we go into. So if the new zero index is less than the current zero index, then we do this. Otherwise, we do the same thing, but then with backwards copy. What was it? Copy backward. There's also ever a case where it is equal, because I don't have to copy anything. That is extremely unlikely. It should be impossible. Pretty sure that it's impossible. Why would that be impossible? Yeah, just impossible. I don't want to think about it. That should really never happen. Theoretically, I should add an assert, but come on. This whole case is made for having something that can be moved, so that then left and right is space. So the only reason why that would not be needed is if it is already there. So it's like a situation like this, and then we would get here, which is possible, of course, if yeah, let's say we try to push something at the end and backgap is just big. I'm not even using backgap here. Ooh, wait a minute. Maybe that's the reason. So backgap is 5 and it is already in this position. Then we would get here because there is only 4 space. Yeah, I also have to take into account that we must end up with front gap here and back gap here after this, otherwise it won't work either. Now assume that that is the case. So if we don't have to move, and that means that it is already in this state, that means that backgap is therefore less than the space that we already have, then we should never have called this function to begin with, because it did fit. think I have to replace size with size plus front cap and plus back cap. Or not. I'm going to add a search. One, 2, 3, 4, 5, 6, 7. So that's 10 minus 3. So capacity minus the zero index minus 1 minus size is then this 4. Must be larger or equal the back cap. Yeah. Yeah, then finally we get to actually reallocate stuff. So I have to calculate the new capacity, which is just more or less doubling the old capacity, right? That's what I said. So we're going to do something like this. It's very complicated. Let's just copy it. I don't think I need this. So let's begin with calculating the minimum new capacity. That then is, I guess, something like two times the current capacity. Or shall I just double the free space? So kind of depending on what the size is. Let me think about it. Kind of like doubling the size then, but then doubling the size plus the front did this, so this. It kind of makes sense, right? Well, that's also the toggle point. Yeah, definitely. So I'm just setting it to this. That is then still correct, which then gives us this capacity for real. And then we can allocate it the same way. And we'll set the 0 index to that, except of course that I need to keep my old buffer in order to copy stuff. Where's my buffer? Here. That's a T pointer. Let's do it like this. Old buffer is buffer, and old 0 index is 0 index. So now I can just copy it. Don't have to do a copy backwards because these are not overlapping. We can just use this. Can no longer call begin and end, however, because I already changed that. Okay, let's not do this then. Let's say T pointer new buffer. Size type new 0 index. Already changed the capacity also. Damn it. I don't think that is that being used by begin and end? Nope, just the 0 index is used. So buffer and 0 index. So now I kept those now, so now I can use begin and end. So now we can just do a copy. And that copy begin and end to the new buffer plus the new 0 index, just like that. And then of course write the 0 index. And after copying we can free the buffer. Buffer, it's just buffer. And then buffer is new buffer. Well, that should work, right? I'm not allocating these things twice. In opacity. That is inside its own scope. Yep. This as well. Okay. Yeah, this is nonsense. The new zero index is more like this one. Okay. No. Could have faster typed it. Something failed. And must mean that the DE vector is not working. don't implement DE vector, idiot. What the fuck? Really? This vector. Nice. Yeah, I guess that will do. So copy this. Mm. Oh, it's 0 and it feels, well, that's can't be any faster. Yeah. Thank you, ChatGPT, for writing this extensive test suite. Yeah, I probably should go into this function and then see why the hell the size is not incremented. Just decrementing 0 index and not. That is -1. Wait a minute. Oh, okay, that's still the case then. Reallocate. Right, yeah. If this fails, I have to set the size. I have to do that anyway, right? Just have to increment size. This is before it, so I have to do it afterwards. So after line 76, I have to increment the size as well. Obvious reasons. What it goes wrong? I'm using 0 index inside reallocate. Yeah. Let's do it like that. Not changing anything. Is it that easy? No, wait a minute. So nonsense. Less than 30, okay. Else, that's the clear. Position is this to 0 bit, okay. So I want to insert actually Yes, including. So it must be 0 up till that point, and then I can insert no. Think like that. Oh, I need an iterator. Tills or something. Yeah, let's call it auto. Iter is div dot begin plus pos. Div in place iter comma value and mirror dot I guess the same thing should work, interface and stuff. No, that won't work. Okay. Auto mirror iter mirror dot begin plus pos. Yeah, let's implement that too. Yep. This one is even harder than the other one, and I feel like taking a break. I'll be back later with in place implementation.